Hi, this is an explanation for problem 59 in chapter 14. This problem reads, the two graphs in figure 14.59 are for two different vertical mass spring systems. Part A then asks, what is the frequency of system A? What is the first time at which the mass has maximum speed while traveling in the upward direction? Alright, so for this one, the mass begins to move down. I guess you probably can't really see the graph, but basically the mass is moving down, but it asks for when it's moving, the first time that it has maximum velocity in the positive direction. So the first point at which it moves in a positive direction is at the 1 second mark, and it reaches maximum negative after 2 seconds. Alright, that's when it's moving down. Then the mass starts moving back upwards. I'm trying to describe this this graph to you. I'll put it up on the screen real quick. So that's the graph that we're looking at. It's got two different systems. But basically, as the mass starts moving upwards again, the equilibrium position, y is equal to 0, and it's at 3 seconds. So, because the maximum speed while traveling in the upward direction occurs at 3 seconds, and then based on the wavelength, we determine that our frequency of oscillation is equal to 0.25 hertz. Okay, so then part B asks, what is the period of system B? What is the first time at which the mechanical energy is all potential? Okay, so all mechanical energy for system B is potential energy when the position is at maximum amplitude, which is at 1.5 seconds. Therefore, the time period for system B is going to be equal to 6 seconds. Now, part C then asks, if both systems have the same mass, what is the ratio of Ka to Kb, or basically what's the ratio of their spring constants to each other? Now, to solve for this, we've got this equation right here. Well, we got two separate equations, really. So T of system A is equal to 2 pi times the square root of the mass of system A times the spring constant of system A. And then we have the same thing for system B, right? So these two equations really come out to T of A is equal to T divided by B. And so we know what our T's are for both systems, 4 seconds for system A and 6 seconds for system B. So if we divide those by each other, then our ratio of our spring constants is going to be 2 to 3.